So the title is Evaluation of Soil Concrete Interface Shear Properties Effect on Foundations in Expensive Soil. Expensive soil are found in many countries of the world. Swelling and shrinking movements occur as a result of changes in volume of soil with the corresponding changes in the soil's water content. These movements of expensive soils lead to ground deformation, foundation instability, and structural damage like lifting of structures, settlements, and cracks. Different types of structures can be affected by this movement, but it's mainly lightweight residential buildings, road pavements, pipeline, and others. Expensive soils are considered the most common geologic hazards. The yearly cost of damages in US is estimated to be $15 billion, which is more than twice the amount of the other natural disasters like earthquakes, hurricanes, tornadoes, and floods. In UK, the Association of Building Insurers reported that a household made claim worth a total of 64 million euros in 2018. In Africa, black cotton soils are mainly found in Sudan, Tanzania, Kenya, South Africa, and they represent about 3 to 5% of the world land area, and the disaster scores are not less. The level of damage caused by this movement of expensive soils depends on the soil structure interaction. In this soil structure interaction analysis, it assumes that the load are transferred to the soil and the soil response are transferred to the structure through a thin layer of soil below the foundation called interface. The authors assume that the interface is a site of significant deformation and stress concentration. Breakage is often observed along this interface. In numerical analysis, it's allowed to consider the effect of sliding, bonding, and separation between foundation and soil. For expensive soils, soiling and shrinkage lead to a shear strength reduction at the soil structure interface. The interface behavior has substantial influence in overall structural response. The demand for infrastructure continues to increase with the worldwide population growth. Expensive soils are prevalent in arid and semi-arid regions and are estimated to cover 20 to 30% of the Earth's area. As these soils still bring significant challenges to construction, understand not only the behavior of the soil, but also the soil-structure interaction is needed. As engineers rely on numerical modeling to assess the stability and performance of structures, the engineering properties of these soils impact on modeling parameters is also needed to be deeply understood. Often in design, the idealization of this support is considered, ignoring the soil structure interaction. Many soil structure interface constitutive models, experimental and numerical characterization have been done, but seismic condition is the one that has motivated the most studies according to the consulted literature. Foundation movement prediction methods is required as a crucial engineering tool. However, the influence of the interface shear properties on foundation movement has not received a lot of attention. The general objective of this study will be then to evaluate the soil concrete interface shear property effect on foundations in expensive soil. The specific objectives are first to characterize the mechanical and hydraulic behavior of the expensive soil. to investigate through experimental study the deformation and failure mechanism at the soil structure interface, and to assess the impact of interface shear properties on swallow pile and craft foundation displacement using finite element and surrogate model. The soil foundation interface plays a crucial role in governing the behavior of foundation. Then, understand more deeply, the unique property of soil interface is likely to be meaningful for geotechnical engineers when designing foundations. Also, more research is required to investigate how interface shear property are critical factor influencing the foundation. So this study will help engineers to assess the reliability, the risk of structural damage and failure, and will allow also more recommendation on criteria controlling foundation displacement. Improvement can then be made to construction in expansive soil, considering both structural and geotechnical aspects. The first significance of this study is that the outcome can be used to estimate the parameters of constitutive model of expansive soil and predict their movements. Also, experimental study capture accurately the property done by numerical simulation alone. Then, by this study, insight that may not be achievable through simulation will be provided, and high-quality experimental data for using in developing, validating, or describe interface behavior will be known. The surrogate model is a powerful tool which allows to explore complex models relating input to output without revealing their inner working. So by this study, a predictive model can be safely used for projects involving expensive soil. So suggestions for regulating foundation movement can be done, and engineers will be better equipped to account for interface properties in the design procedure. The finding of this research would be very helpful to many stakeholders, including engineers, researchers, and all the construction industry. In this study, we will be focused on experimental investigation of expensive soil in site located in Judas subcounty, Kenya. Only the mechanical properties of the interface and the impact on foundation will be studied. Modify CAM claim model, finite element analysis, surrogate modeling with decision tree algorithm are proposed as prediction tool. The research may be limited by certain hypotheses. The climate change impact on the shrinkage swelling of expensive soil will be not analyzed. The other factors that can influence the performance of foundations, such as construction practices and growth characteristics, are not taken into account. Also, due to the numerical modeling, some idealization will be required. There are many constitutive models to describe the expensive soil behavior. The modified clay model is an elastic plastic model that can capture the volumetric behavior of the soil. It describes the important aspects of soil behavior like strength, compression, or latency. It needs 5 parameters. Soil composite interface also have many constitutive models, such as the hyperbolic model developed in 1961. Also, the zero thickness element is a model compatible with available constitutive model and contains 2 spring node elements. In the study of Theodosio in 2020 about the relationship between reactive soil movement and footing settlement, the interface is not considered between the footing and the soil. Also, Green and all in 2022 did an experimental study on the shear characteristics of different Python interfaces, but the influence of the interface properties on the file displacement were not investigated. Also, in his study on residential house foundation on expensive soil in 2023, Tabasun and Bulum have developed a model that it's not suitable for slabs. Also, THESIS and all in 2021 in the study about the influence due to interface in finite element modeling has developed a model, but the interface shear property influence on the footing were not studied. In summary, we can say that many study on expensive soil property and MCC model parameter determination have been done. Also, experimental studies, numerical modeling and factors affecting the shear property of the soil concrete interface have been studied. Foundation behavior in expensive soil have also been studied by many researchers. That the impact of expensive soil property on MCC model parameter is not known. The relationship between the interface shear property and foundation displacement in expensive soil is not investigated. And in the previous studies, any method to evaluate the interface shear properties impact on the foundation were not present. This is the conceptual framework with independent variables and dependent variables for each objective. For the methodology, each objective is divided in many activities. For the first activity, objective 1, we will perform many soil tests in purpose to do a classification of the expensive soil. We expected to have at the end the physical property of the soil, like particle size, natural and critical phosphor content, chemical and mineralogical composition. For activity 2, to identify the mechanical and hydraulic property of the soil, we expected at the end the compression index, swelling index, void ratio, swelling potential, free expansion ratio, etc. In activity 3, to estimate the parameter of the MCC soil model, we expected to have the consolidation species Q and P, the critical state line M, and K and lambda. In activity 4, we will use MATLAB optimization tool with a method proposed by Doherty and all in 2012. We will also do a sensitivity analysis to determine the impact of engineering property of the soil on the MCC model parameters. For the first objective of for the first activity of objective 2, we will determine the property, the mechanical property of the concrete. We expected to have at the end the density, the compressive strength, Young and shear model, Poisson ratio, and surface roughness. For the second activity, we will use different tests like direct shear interface test, SEM analysis, and X-ray tomography of the shear interface to characterize the interface shear properties. We will use at the end a regression analysis of the interface test data to determine the parameters of the hyperbolic model. For the first activity of objective 3, Placis software will be used to model the the soil using the MCC model parameters. The simulation of soil and shrinkage will be done by applying a volume strain. We expect it to have at the end the initial stress distribution within the soil and the deformation and stress distribution after the volume change. For activity 2, the model will be validated by using a secondary data from a case study of Karunarate in 2016 research. We will do a model-to-model comparison. The model prediction will be compared against observed data from Raybrook site expensive soil in Australia. The seasonal variation of soil moisture content and the subsequent ground movement was recorded at different depths during 2 years. We will also do a error analysis in expectation to have an accuracy of the model. For activity 2, we will do a parametric study by the evaluation of C and phi in purpose to have the influence of this variation of parameters to the foundation displacement. For activity 4, a predictive model to evaluate foundation displacement based on the shear property will be done by using the data from the simulation in Praxis, modelization using decision tree algorithm through random forest, and also optimize the model by using MATLAB surrogate optimization tool. This is the background of the research, which will cover 31 months. The budget that we propose is about 8,000, and we expected at the end of the first objective to have the chemical, physical, mechanical, and hydraulic property of expensive soil, the modified sampling model parameters, and also the properties influence on these parameters. For the objective 2, we expected to have the mechanical properties of the soil concrete interface and the hyperbolic model parameters. Objective 3, we expected to have a predictive model to evaluate foundation displacement based on interface shear property. The output expected is the publication of at least 2 scientific articles in the PhD citation. Here are some references. Thanks for your kind attention.
All right, Ceres.
Yes, sir.
I have heard your presentation. Now, one thing, so that before I forget,
Yes.
I'm not quite sure whether you are given 15 minutes or 20 minutes to present. Have you been told?
Yes.
How many?
15.
Yeah, so you need to work on that because you spent around 19 minutes.
Yes.
And one of the area, of course, this one comes with practice. You need to practice
okay.
by yourself when you are timing yourself.
Yes.
Now, the other thing, one area I found that you could, of course, it should be there in your document, but for the sake of saving time,
yes,
slides on significance and justification.
Okay.
Yeah, those 2 slides, I feel like you may not need to present them here.
Okay. Okay.
I don't think there's anybody who will say that why are you not presenting the ABCD? Okay.
Okay.
Then on the scope, okay, we are going to check one by one. There's something I have noted on the scope. But that was the first thing that I thought is important, so that you can try to save on time. The other thing that you can look into so that you can utilize your time effectively is on the references. The document you sent to me have got about, I don't know, 3 or 4 slides on references.
Yes, 3, I think.
These are just illustrative. These are just to show us that you are referring to some papers you are reading. Eh? So what
Yes.
you do is that you select the very best. You select the very best and the very strong papers that are helping you bring out the gap.
Okay.
Yeah, and the latest.
Okay.
If your area of research is interesting, then you should have good references which are not older than 5 years. Now, this
Okay.
being the case, could you go to the background on page 5, on slide number 5? Yeah, the first one, the first point.
Yes.
I found that okay, the way you have itemized them is good, because for each point you are trying to show us a certain aspect. Right.
Yes.
The second one, you are talking of how numerical analysis, what they have achieved so far. The
Yes.
third point, now you are talking of the soil structure interaction. The
Yes.
first one, you are talking of what? What does it is it trying to bring out?
The first point,
Mm.
no, just like a definition of interface.
Oh, it's a definition. It was defined a long time ago. That's why I was wondering why you have very old references.
Yes.
They are very.
Uh, should I remove this point?
No, it's good since you are going. You are narrowing down. Of course, like the first one, I expected to be related to kind of the first objective. These are material characteristics.
Okay.
Stress concentrations, deformations. But of course, these are observation, introduction to the issues of expansive soils. My only concern is the issue of the references. They seem to be very old.
Okay. I will work on it.
Okay. Now let's start from the title. Yeah, at this point, I don't have any objections to this title. And just a concern, a question. Your work is focusing on shear only.
Yes.
But shear properties of the interface, at the interface, soil concrete interface.
Yes.
So you are not covering issues to do with the settlement due to expansion, shrinkage behavior.
Yes. Because after the characterization of the interface in the third objective, in the numerical analysis, I will assess the displacement of the foundation.
If that is the case, so you are going to measure displacement. You are going to have result for displacement.
Yes.
Is that covered in the shear? Because now your title is focusing on shear only.
Yes, because at the end of this analysis,
Okay.
I plan to have a relationship between this displacement and the shear property of the interface.
That's why I was saying I like the title. The title is clean. I just wanted you to be cognitive or to be aware that such a question may arise, because somebody may feel like you have constrained yourself within a certain area, but then your results are showing are showing output outside of the title. Okay, but if you are saying it's just a relationship, then I don't think it's a major issue. Okay.
Okay.
Then background slide number 3. I know I always advocate for people to use graphics, which is a very good way of presenting. But I also insist that any graphic that you use should be related to what you are talking about. Okay.
Yes.
Now, I'm wondering, like on the right-hand side, are these failures due to cracking? I mean, due to foundation, like the where we are seeing soffit of the roof. What I can say the figure number. Of course, like the second one, the first one, okay, the second, the third, the fifth, and the sixth. But the fourth,
Yes.
it seems like at the corner, that's a corner. I don't know whether it could be a column there, but it seems like it's a separation between the wall and whatever it is there, whether it's a column or that in that corner. Is it justifiable that that failure is due to settlement of the foundation?
I think.
You think so?
Yes.
Yeah, because even the fourth one, I mean the fifth, you see,
Yes.
when we are talking of foundation and expansive soils,
Yes.
I think it's better to show, unless you have some reference which people have noted that it was due to that, it was due to settlement. But if you are not quite sure, I like the way you are showing the one that we can see the ground. Yeah. The one that you can see, even if you are seeing the building, we can see the ground, so that we can say, we can say that the failure is as a result of the settlement of the soil. You see, of course, there are many things, many issues can cause cracking on a building, right?
Yes.
And not necessarily settlement.
No.
It could be even poor anchorage. If you have a column and then the wall and then they're not properly anchored, it could result to that. Okay, that's not a major issue. I just wanted to, you are becoming an expert in this field by the time you graduate with your PhD. So apart from just passing the unit and graduating, or having your thesis approved, proposal, and you do your work, you're also being sharpened, equipped, so that when you go now to train other people, you can pass on those skills.
Yes.
Yeah, so one of the things is that any figure you put should be related to what you are talking about, with no major question. Then the other thing is, where possible, you have taken these figures from somewhere.
Yes.
It's always good to cite the source, because these are not from your test.
No.
Okay, you can just say source. Then if it's from SARI 2014, you just say source SARI 2014 into brackets as a caption.
Okay.
Okay, there are things that are obvious. You see, yeah?
For all the pictures in this presentation.
No, yeah, throughout the presentation, but you can do a representative. You can do a representative referencing. Like you see here, you have so many photos. You might not be able to do for all of them.
No.
Maybe you have taken them from different sources.
Yes.
But if you can just write at the bottom there, the bottom, where you have these grouped photos, there are 6. At the bottom, you can say source. Okay? Source, colon. Then if you sourced from 3 different people, you can say, let's say they are from this Tabassum and Barut, Dev Kotel, 2022, and you just write them there. You just take these references. Source, then those references.
Okay.
There are those which are obvious, like the first one on the left-hand side, the issue of shrink and swell. You are just showing us the cracking. This could be from literature. This is a common, is a well-known fact about the cracking of expansive soil. This whether black cotton soil or clay soil. So that one maybe you can put, but it's not a mandatory, because this one is well known in literature. Okay.
Okay.
Yes. Now, the slide number 4. You see, there is also something we call flow. Why in presenting your work, you want to start with the general issues, and then you want to start narrowing down to specific aspects that you are looking into in your work, right?
Yes.
So the first slide, the slide number 3, is very nicely explaining. Already you are in structural engineering in this, for that slide, right? The previous one.
Yes.
You are talking of the issue of expansive soil. You are showing us the effect. Okay. So then going back to this slide, it's like you are going backward. I mean, going forward to slide number 4, but now you start talking of the issue of distribution of expansive soil across the globe. I feel like you are diluting your statement in slide number 3. Okay. Either this one comes before slide number 3, or to me, this one could be made as a statement in the justification. You are trying to justify why this study is necessary. And you want to show us that across the globe, there is a distribution, how these expansive soils are distributed, right?
Yes.
So to me, if you really want to maintain it, if I were you, I could remove it and just have one statement in slide number 3. If not, then I could put this to be slide number 3, then I bring slide number 3 here to slide number 4. I just interchange them.
Okay.
Okay, because we come from general global issues, then we are settling down to narrow down the issues of to do with soils.
Okay.
Because from that slide now, go to the next slide, you are supposed now to start singling out your what other people have done on the same, right? Slide number
Yes.
5. Yeah, so you see here now is where you are talking of what is already known now from past studies.
Yes.
So you understand my concern in terms of the flow of
Yes.
information.
Yes, I understand.
Good, good. So you might not remove it, but interchange it so that you have a nice flow here.
Okay.
Now, let's move to the problem statement. I feel there is something that can be improved on the same. One, the first column,
Yes.
to me, should have been covered in the background. In the problem statement, you don't want to spend much of your time explaining general issues. You want to explain the specific issue that you want to handle.
Okay.
And to me, the specific issue, I could start in the second column, where you are talking of how in dealing with foundation, we idealize that the supports are fixed. That could be my starting point. Because when you start with the first one, talking of the demand for infrastructure is increasing, this one, I believe you have mentioned it in the background, or you should have mentioned it in the background. The issue of expansive soils covering wide area is the one that you have already talked about, right? So you find like they are not bad. This one, you can have them in the first paragraph in your report. But in the presentation, you don't want it to waste your time. Okay? You don't want to have a repetition. Because if you, like the second statement in the first column, you agree with me that this one is covered by the figure you are showing us of the distribution of soil across the globe, right?
Yes, yes.
So you don't want to waste your time on that. And again, you don't want to put, people are just listening to you the first time. And they don't have much time because, after a minute or so, you are going to jump to the next slide. So in the presentation, you want to capture their attention very quickly and also make them understand specifically what is your problem that you are looking into. So in that case, it tells you, try to remove as much as possible generalized issues which might confuse or, they deviate the attention of your listeners, right?
Yes.
So I have already told them about the issue of expansive soil. I've told them what other people have been trying to do. So here I come and say, we know how people consider support, that they are fixed. Okay? But then we know with expansive soils, there will be movement due to the shrink swell behavior, right?
Yes.
Yeah, so to me, I felt like after you have mentioned about the first statement in the second column, because that's where we are starting to. So if you agree with me, we can remove the first column.
Okay.
Completely.
Okay.
Then the second one is when we are saying, after you have mentioned about how people have idealized the support to be fixed, then I would bring in the aspect of this. Why this is not true is because of the shrink swell behavior of expansive soils. Okay. Then something else I didn't quite understand is the third statement, where you are saying, but seismic condition is one that has motivated most of these studies according to consulted literature. Okay.
Yes, because in most of the study that I found, it's also about for the interface characterization or modeling. It was done in purpose to understand the seismic response of the soil in the structure. I don't know many about the expensive soil movement.
Wait a minute. You are saying there are no studies on expansive soils?
No, they are more study on interface of in seismic conditions than study about interface in expensive soil.
Oh, they are there, but they are not many.
No. The statement is it confusing?
Yeah, because in your literature review, you already reviewed papers which are dealing with the shrink swell behavior.
Yes. Okay. Or maybe I can remove if
Yeah,
it's
yeah.
confusing.
My concern was like when you move to the side of seismic,
Yes.
we are bringing, to me, we are bringing in another different aspect that is not the focus of our study.
No.
This is about loading. Seismic, eh?
Yes.
Your study is focusing on lateral loads on axial loads due to the self weight of the life loads and the dead loads from the structure, right? Transfer to the ground.
Yes.
So you are not concerned, that is not a variable. You are not concerned about the nature of loading, whether it will be lateral load or axial load. You are focusing on axial load, right?
Yes.
So when you now bring in the seismic, seismic, these are actually, they are multi-directional roads. So it's like you want to say, I also want to have a variable which is on the nature of loading, which to me is the focus of your work.
No.
Okay, so the third statement there, it kind of breaks the flow of what it is that you want to tell us you want to do. And at the same time, it's going to the direction that is not the focus of the current study. Okay. So to me, the first one, we are saying fixed support. Next, you should show us why the support actually are not fixed per se for expansive soils.
Okay.
Okay.
Yes.
Now, I might ask at this point the same question I asked when you are preparing your proposal last semester.
Yes.
Do we allow in normal design considerations? I don't know whether you remember that question. I have my notebook. I'm trying to recover where I was making notes. But I think the question was, in normal practice, in design codes, do we allow buildings to rest on expansive soil which have not been improved?
All right. Yes. We can do some improvements on the soil.
Okay.
Or also for the foundation, pipe is also a good option.
Or the pile footing.
Yes.
Or which works via friction. Because to me, I believe,
yes,
once if you're just talking of the pad footing, okay,
yes,
or where we have shallow footing, then we are talking of structure resting on a firm foundation, a foundation that have attained some certain engineering properties. Okay.
Okay.
In clarifying your problem, once you make a statement like this, which is helping you build your case, because when you say, I believe what you want to say is this: although we idealize in design, we idealize like our supports are fixed, that the buildings are resting on a fixed support. However, due to the nature, the shrink swell behavior of the expansive soil, so you see people come into place and then want to know, why are we dealing with the shrink swell behavior when this foundation is resting on a soil which has been either treated, if it was expansive, problematic soil has been treated, okay?
Yes.
I'm not saying it's the way you have put them is not wrong. The only thing is that how do we build a strong case? Because this slide only, if you
Yes.
agree with me, this slide only is the one that tells us, is there a problem worth investigating? Is there a problem to be investigated for the next 2 years? And after this problem has been investigated, are we going to generate new knowledge? Are we going to advance something? Okay. So in doing so, it means the problem has to be well articulated. It has to be very clear to anybody who is listening, to anybody who is reading this work. This slide is the deal breaker. This slide is the one that says there is a problem, and he or she have showed us, has broken it down very well to us, and we feel like there is something worth investigating that I have not received much attention so far. So that's why you feel like I'm feeling there are things you need to remove, like the seismic, so that they don't, they are not helping you build your case per se. They are, you don't want, at this stage, problem statement, you don't want to be so general. You want to break down your story. You want to have a certain flow that you make people flow with you. Understand, this is the fixed support. This is not necessarily the case. When we are dealing with expansive soil, the cyclical behavior occurs. There is the interaction between the structure and the soil. And the interface zone is where now we are focusing on.
Okay.
You feel that yes?
Yes, I want to mention that in my study, I want to focus on lightweight buildings, like residential building, because it's the most that are affected by expensive soil. For example, in my country, individual people don't have money to treat the soil or build the high-rise building. So it's just low-rise building that they build. And because they don't have money to treat the soil or to do a lot of things, they just build on this soil. But they can use, for example, not swallow foundation, but it's not pipe. I can say it's in the middle of swallow and pipe foundation, and they can also add that for the foundation. But the problem is still there after there are many issues that came.
Okay.
That come.
Yeah, I understand you. I understand you.
Mm-hmm.
So, and something else, so that before I forget,
Yes.
like every statement, the second statement you are saying many soil structures, this work have been done. Could you give some references? If it's like Michael 2020, Simon 2022, put some reference there.
Okay.
Yeah. Even the other one, the foundation movement prediction is required as a crucial tool at an engineering. Good. Now,
Okay.
foundation movement prediction is required. So the question is, we have had prediction methods, is it?
Yeah. Yes.
So before you mention here for expansive soil, can't we mention something after you have removed this one of seismic condition? Can't we have a statement telling us what other prediction methods are there, like what have been done so far?
Okay.
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 So that by the time you are saying foundation movement prediction, it will not sound like you are the first one to do that. It must be an improvement. So you can say like foundation movement prediction method that are there do not capture. Maybe like you are saying there, the interface, the shear properties at the interface. Maybe they just concentrate on the properties of the soil, the hydraulic properties of the soil. Okay. So your point here comes out because your summary point is you are focusing on the influence of the interface zone. the interface between the foundation, the structure, and the soil, right?
Yes.
So the last statement is very clear. So, but the second last statement is not, it sounds like you are the first person to attempt here, this.
Okay. Okay.
Let's show us the methods. They are prediction methods, but they do not consider the interface behavior, the behavior of the interface, right? Okay.
Okay.
So we
Yes.
are in agreement. In summary, we are saying remove the first column. In the second column,
Yes.
remove the third statement about the
Statement.
segment. Then modify.
Yes.
Then no. After you remove the third statement, in the
Yes.
first you are talking of the fixity of the foundation. Include a statement showing us why there is not true, entirely true. You talk of the for light structures resting on unmodified or partially modified expansive soil. And this is the point. If you can change this figure you are representing here, you know, once you remove the column on the right, you on the left, you have a space. If you can bring one of the figures, if you can bring one of the figures that you showed in the background, where we are seeing expansion on the foundation and the building, because this one in black and white, we can't know what causes the failure. It could be the earthquake.
Okay.
Okay, but the other, there's one photo you are showing in the background. I don't know whether it's like number 4 or 3, where we can be able to see. Okay.
Yes. Okay.
I think this could be slide number. No, this could be figure number 3, or if you can get a better one.
Okay.
Or even the first one. You see the first one you are seeing, but this one you're just seeing the building tilting.
Yes.
Building tilting. Okay, the second one you are just seeing cracks on the road, pavement. The third, not very clear. But if you can be able to get a figure, a photo that is showing swell on the foundation at cross ridge, and then the building we can see, because of the heaving, we can see the building being affected, whether it's tilting, whether it's, you know, it's cracking. You know, we can see both the soil, the foundation level, and you can see the building. So that on slide, in the problem statement slide, yeah, once you put that very clear figure here on the left where you have removed that text, now you can be able to show people can see that there are buildings which rest on those type of foundations, right? Soils. Okay. So that now that this one the statement you are adding after the first one, where you are saying idealization of fixed support. However, for buildings resting on modified or partially unmodified or partially modified expansive soils, failure due to shrink soil behavior is eminent, as shown in the figure, as shown in the photo alongside. Okay. Then you move to prediction method for ground foundation movement. Prediction method for foundation movement so far have been studied, but they don't capture the interaction between this and this. And for each one of them, you are putting a reference, so that if somebody wants to see who have attempted or the models that are there, then he or she can go to that reference. And then now you say the focus is the shear, the inference. And you see here, at this point, when we are saying that the prediction method, can you go to the theoretical literature review? So these are models, right?
Yes.
For expansive soils. Okay. So you're saying, like, for example, the modified Camp-Cray model captures the volumetric behavior. So these are the behavior of the soil. It captures the soil behavior, strength, compression, and dilatancy, right?
Yes.
But you see, this model in itself doesn't capture the interaction between the structure and. Okay. So the same case you are saying, there's some people who have done soil concrete interface constitutive model. Okay. What's not captured here, because we are saying this one is capturing the soil concrete interface. Why do you think this model needs to be improved by your work?
I don't want to improve these models, but to develop another one.
Why do we need another model? Why is this one not adequate?
Because for example, for the modified chem clay is only a model for the soil, and for the second one, hyperbolic model is only about the interface. But me, I want a model that can help to have the displacement of the foundation based on the shear properties of the interface. So me, I want to use in reality these two models, because I will use the both in my numerical modeling.
So you want to have a hybrid model.
Yes, if I can say that.
Okay. So the one that captures soil properties and the one that captures the soil concrete interface.
Yes.
And even if you are not going to define them here, you need to know at the back of your mind. If I ask you, for example, what does gamma represent in the hyperbolic model? What does that symbol gamma represent?
Okay.
Yeah, you need to know all those symbols, what they are.
Okay.
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 Because these are the ones that will make somebody understand what is the difference between the MCC model, hyperbolic model, and now your hybrid model. They will appreciate. Actually, when you show us this model, the theoretical models, I know you just showed us they are there, but it's also good because you want to get a gap, right?
Yes.
It's also good to critique. Tell us, okay, not spending too much time, but you say modified concrete model captures ABCD. And how comes, by the way, you don't have that MCC model? You can't have mathematical expression of it here?
I searched that at this point. In most cases, this model is already implemented in the software like Plastic.
The
So
MCC model.
yes, so we just put the parameters that we calculate with the laboratory work, and we have the result. But I can find some expression. I think yes. I think I can
Yeah.
find.
I believe that if they are mathematical input parameters, then there should be a mathematical model, most likely.
Yes.
So look for it, and if possible, then have it here.
Okay.
So that when we are listening to you, we'll be able to really appreciate and understand what it is that is happening. We can be able to appreciate the difference between the two models, so that by the time you go now to tell us what other people have done and then what you are proposing to do, we'll be able to appreciate. For example, go ahead. Just go to the summary. I don't know whether it's here or it's in the methods. You need it. I feel it's necessary. You don't have the final form of the model. They should be slide number 27. 7.
Yeah.
I feel in this place, you're going to develop a model.
Yes.
But at the end of it all, are you going to have an output, a mathematical model?
Yes. That's why I want to use the decision tree algorithm and the MATLAB optimization tool. It's because from Flaxis, I want to have the displacement and the shear property related to the displacement. I will do a parametric analysis in Flaxis. So then I will have the data and then use the data to model.
Okay.
To form the relationship between these shear properties and the displacement.
Then at this point, because this is a very formative stage, This is
Yes.
another stage. So you don't know how the model will look like, right? But you
No.
know what parameters you want to relate. You want to relate displacement
Yes.
with shear properties and all that. So
Yes.
I would like you to propose here a mathematical function.
Okay.
You know how we write, for example, you know how we write, I can say A is a function, equals a function of B, C, D, E. Okay?
Yes, I see.
So in that case, I have not committed myself to know whether A is directly related or is inversely related or is a square root. But I'm just saying A, the displacement equals F into bracket, F to represent a function, F into bracket, then you put all those variables which you want to model to relate with the displacement.
Okay.
Because even when we say shear properties,
Yes.
what are these shear properties of the interface?
C and C.
You need to put them, all of them there. So why? Why is this important? As you propose, this is a proposal first stage. As you propose, now people who are following you will now want to know, why do you think like displacement is only related to these three variables or four variables? They will even be able to judge like whether your model is an advancement to the existing models or it leaves out things and variables which might affect the output. So they are able to compare between your proposed model with the existing models. But now when we look at this way, this slide, when I look at slide this 27, I can't say much. I can't be able to give reasonable comments of your expected model, right? So a predictive model to evaluate foundation displacement based on the shear properties of the interface, right?
Yes.
So that model, after that statement, write that mathematical expression.
Okay.
Okay. You understand when I say you use F function of.
Yes.
Yeah. So that now you are not going to say whether this is one of 3.4. You don't have those values. Okay.
No.
1.34x plus 1.34 over displacement. You know, you don't have that. That is the one that you are going to model. But at least we know which parameters we are going to model. Okay. So you input that. Then at the same time, this one you might not need to explain too much at this stage because of time, but have this answer at the back of your mind.
Okay.
If somebody asks you, why do you feel like utilizing MATLAB and Praxis? There are many models. Why these softwares? Why?
Because I don't know. MATLAB, I a bit about. Also about plastics, I know a little bit. So it's like the constant way.
That's not a justification. You know, you are a student. You don't have to know something now. You just need to know what it does and reading literature, how it works best. Because somebody may wonder, why are you not going to something like Python? You can still study around Python. You can still learn Fortran. So it's not this one. This one is not, it doesn't mean that using MATLAB is bad, but people really want to know, have you done your background? Have you read even theory? Okay. Have you tried to look out for are you using the best tools that there are? Are you investigating? Have you researched enough? Okay. So always have a soft answer for these kind of questions. These are not the kind of question that will stop your proposal from going through if it's good. But you may find somebody who have used these softwares and then he or she tells you, why are you going for this? Maybe they used another software, right? Then they push you to that software. If you are not well grounded, you know you are going to move. So you need to have some reasons why you are using this software. Okay.
Okay. Can I say it's because they are good software that have been proved that done very well results.
Of course, you can even use the answer like from your reading of past researchers. We have a number which who have attempted to use these softwares, and they have utilized them successfully.
Okay.
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 You can also say the exposure and the availability as a second answer.
Okay.
Yeah. The concern I had about objective 3 was that it didn't sound very specific to assess the impact of interface shear. Just say
yes,
to determine the influence. To determine the influence of interface shear. Yeah.
What is influence?
Influence. You can even say to determine the impact. The word I want you to remove is assess. Instead of assess, let's use the word determine. Because in assessment is general, very general objective.
Okay.
You can even say to determine the effect.
Okay.
Now, my other question is, you want to handle all these foundation, pile, raft, shallow?
Yes. This is what I have in my mind.
It's not too expansive for your work. But anyway, this is modeling.
Yes. Because I want to at the end compare and can say what condition will be more suitable or can be better for the soil I will model.
Okay, let's move to the scope. I think I jumped. I should have continued sequentially. Let's go to objectives first. Because it's good you know these. After the problem statement, people are interested at this stage. People will focus will have their focus on the title, the problem statement, the specific, the objectives, the research gap. That is the focus and the conceptual framework. That is the focus because they want to understand whether there is a problem there. Okay, so the first one to characterize, of course, the third one we have said just use the word to determine the effect. Now, the second one is to investigate experimentally